Hey guys, welcome to this session by Intellipaat. In this session, we're going to look into Google Cloud Platform interview questions. So we'll be looking into three categories of those questions. We'll start off from basic, then intermediate, and finally we'll arrive at advanced questions. And before moving on with this session, please subscribe to our channel so that you don't miss our upcoming videos. And also leave a like to our channel and to our videos if you like our content. So now let's begin with this session.
So now let's start off with the first question. So let's start off from the very basics. So the first question is going to be compare GCP with AWS. So now we all know that AWS is the number one cloud provider in the world according to its market share. That is, it owns the most of the entire public cloud market share. It shares it with Azure, GCP, Alibaba Cloud, IBM Cloud, but it holds a complete chunk of it. And GCP is in the top 3 right now, but it seems like they won't be in the top 3 very soon because Alibaba Cloud or Ali Cloud is catching up behind it. So now some differences are, first, GCP and AWS has a lot of data centers than GCP, but right now GCP is trying to bring up their numbers every single year. Market position, GCP is in top 3, which basically is it's in the 3rd position. AWS is in the 1st position. Entry into cloud, GCP came at 2011 and AWS came into the cloud industry at 2006. So basically this 5 years gave AWS a huge lead in the market share. So you can also talk about they provide similar services, but the company who's providing those services are different. That is, here it is Amazon.com, which owns AWS. There it's Google, which owns GCP. So now they both provide same type of services. So they both provide virtual machines. They both provide cloud storage and database engines which is running on the cloud. But the company is different. That's it. And how they are providing and the pricing points will be different. Second question, mention platforms which are used for large scale cloud computing. So now you've already seen differences between Google Cloud and AWS. So now what are the other companies, which are the other platforms which are providing large scale cloud computing? That is the cloud computing providers who basically tie up with companies who need 100,000 or 200,000 servers, basically a lot of servers and a lot of compute power. So what are those companies? So first I would obviously say AWS, then Azure, then GCP. Then there are other cloud providers, alternative cloud providers who are really coming up in the industry. Alibaba Cloud, IBM Cloud, and Oracle Cloud. So these are 3 other alternatives. Explain different models for deployment in cloud computing. So there are mainly, let's say, 3 models. One is public cloud, private cloud, and hybrid cloud. So now community cloud has also been included within these 4, but the main 3 things or the main 3 deployment models are public, private, and hybrid. So now public is basically a cloud provider who you can use, a company can use. So basically anybody can use that cloud provider. And when you create a server, that physical hardware which that server is running could be shared across multiple users. But if it is a private cloud, in that case, you will pay more money or maybe sometimes less money if you're taking a contract or a discount offer for a long-term period, for example, 1 year. So in that case, the physical hardware where your servers will get created will be basically dedicated to only your company or only you. So basically they dedicate that particular server or multiple servers which you need to only you. So whenever you create a server, those servers will be created on the physical hardware which is dedicated to you, and that physical hardware is not shared with anybody else. So most of the companies don't take either private or public, they go with an hybrid cloud model. So in this case, private plus public. Some of their applications which are mission critical, which has very sensitive data, will be stored in the private cloud. And public cloud, for example, applications which users can basically check it out, users database information, so not sensitive information, so normal profile creation or something like that, so that can be hosted on a public cloud. How users can gain from utility computing. So utility computing is a service wherein you get pay as you go and on demand services. So first let me just explain what these 2 terms are, pay as you go and on demand. So first of all, pay as you go in the sense, so normally what do, you go to a shop, you pay the money for a certain product, get the product in return and leave. This is not pay as you go. So you pay upfront for the product. But pay as you go in the sense it's like a credit card bill, or it's like a postpaid connection, phone connection, or something like that. So basically you use the cloud provider, you use all the services, you basically create servers, database engines, cloud storage, you use all of this, and you can basically check your usage and pay at the end of the month. So as you go, as you need these services, you can basically pay at the end. And on demand in the sense, servers which you need can be created immediately. Whenever there is a demand, they have their services and it will be available for you and they'll give it to you. So there is no let's say there is no delay in service provide. So they don't make any delays in providing that service. Whenever you need the service, whenever that service is in demand, whenever you need 10 servers, you can create it and it will be provided to you. And on demand services, in which the provider offers to manage and operate the computing services, you can choose which service to access, which are deployed on the cloud. So now when it is pay as you go and on demand services, whatever it is, the cloud provider who is offering you these services, or these for example, you want a server from AWS, so you basically launch a server. So now that server is running on the physical hardware of an AWS data center, and the data center is managing that server for you. They'll manage it, they'll operate it for you, but you can access the server with certain remote credentials, and you can basically access any service like that, and that's what they provide. So that is pay as you go and on demand services. And as a common user or even a company, you can basically gain reliability and fast access to certain services. For example, if you want to host a website immediately and you don't want to go to a hosting service, you can do that in a matter of minutes. Fifth question: when you are transferring data, how do you secure it? How do you ensure it is secure? So to ensure that data which is being transported is secure, you should check the encryption key implemented and there is no leak in the data. So it is 50-50. That basically means it's a shared responsibility of you and also the cloud provider. So the cloud provider should make sure the cloud storage or the physical hardware which the data is being stored is secure and safe. Their network should be safe enough so that there is no unauthorized or any attacks. And your part, that is the data which you are storing, also should be stored in a proper way, and it should be encrypted. Only if it is encrypted, even though some data leaks, it cannot be decrypted and viewed until they find out what is the key to decrypt it. So you can use public key cryptography, so where a physical key is visible to everyone. For example, when the encrypted data is moving, public key will be attached to it and it will move with the data. Even though the hacker gets the public key, they cannot decrypt it unless they get the private key. So the private key is not stored in the cloud storage, it's stored in your local PC or in your local server. So now when the data is before getting into your system, you will have to use the private key to decrypt the data. So basically the private key is like a key and the public key is a lock. You use it to open it and you basically decrypt it. So describe the security aspects that the cloud offers. So access control is one of them. It basically offers control over the users. So you can create users, you can delete users, you can create a user and give them certain permissions so that they cannot use any other service or they cannot do any other things which you don't want them to do. Then identity management. So you basically provide authorization for certain application services. For example, let's say you are creating two users. So one user is a developer and one user is an accountant. So for the developer, you don't need to provide billing information. So the developer doesn't need to know how much it is going to cost for this. They can basically check it out in the calculator and in the AWS simple calculator or any calculator which is available for any cloud provider. So now let's say the developer doesn't need billing information and the developer only needs like 3 services. Let's say it is in AWS, let's say it is EC2, S3 and RDS. So the developer needs only these 3 services and only need permissions to view these 3 services. In that case, you can provide them authorization by creating a policy only to these 3 services and they cannot view or access any other service. Same goes with the second user, which is who is an accountant. So in this case, you can provide the accountant only the billing information. So because an accountant only needs that and they can basically take it down. Then authorization and authentication. This security feature lets only the authenticated and authorized users to access the applications and data. So this happens with every single website. Only authenticated and authorized users can basically log in and use the applications and data. So these are the 3 different aspects which cloud is providing. What are the various layers in the cloud architecture? Okay, so let's look into this. So mainly there are, let's say 3 layers, but over here there are 4 layers. Let me explain that. 3 layers in the sense there are 3 different types of services. One is software as a service, one is platform as a service, and one is infrastructure as a service. So in infrastructure as a service, there are 2 different parts, and in the top, which is software as a service, let me show you this. Yeah, so over here you can see the end users are the people who are using the services, the applications. For example, as a user, you're watching this through YouTube. So YouTube is hosted in a cloud service, and basically YouTube is a software as a service given to you where you're logging in and using the application to view videos. So the applications are in this layer, which is basically software as a service. So Google Apps, Facebook, YouTube, Salesforce.com, any website which is hosted on a cloud is software as a service, because you cannot view YouTube's code. Maybe you can view YouTube's HTML code when you inspect element or when you just click on F12 by opening the developer preview. So now that is not the code. You cannot obviously view YouTube's backend code because it's stored in their own personal servers or in a Google Cloud server. You can only view the software. You can only view the application. In that case, it is a software as a service. Second comes a platform as a service. So in this case, you will be provided with a platform which you can use to build certain things. So over here, Microsoft Azure, Google App Engine, Amazon Simple, DB or S3. So if you know about Elastic Beanstalk in AWS, that's the best example. So let me just brief it to you. Basically, you have a website in which you can upload your code, and it'll automatically host it for you in a certain type of server which you need. So it's basically a platform which lets you to do things. So in the first case, it is just the software where you can only view the software and use the software. You cannot view anything else. Platform as a service, you will be given a platform in which you can do certain things. And finally, coming to infrastructure as a service, which is the most popular type of cloud services which are used, because when you use AWS or GCP, or when you use let's say Azure, so in that case, let's consider GCP. So in GCP, what do you want? You want to basically create servers. You want to host your website on that server, and you want to make users upload certain images, and that images will be stored in the Google storage, and whenever the user needs to download it, it will be downloaded from the storage itself. So to do this, you obviously need hardware. That is, for the server to run, you need a physical server in the Google's data center. So that is provided by Google. Same thing goes with storage. They'll have storage units in which the images will be stored. So in this case, you are given access to the actual hardware. You are not given only access to the software. You're not given access to just the website, and everything else will be taken care of Google or AWS. But in this case, you are given access to the service or to the infrastructure or to the hardware itself. You are given access to basically the servers, you are given access to the database, you are given access to the storage. So these are the 3 different types of layers: software as a service, platform as a service, and infrastructure as a service. Infrastructure as a service is the most popular type of service, which is basically provided by GCP or any other cloud provider. So one more layer which I forgot to tell is the physical layer, which basically for the infrastructure as a service layer to provide you certain things. For example, if you want to launch a server, so the server has to run in a hardware. So that hardware is basically running in a data center. So even this basically comes under the layers. Now coming to what are system integrators in cloud computing. So the cloud can consist of multiple components that can be complex. Now the system integrator in the cloud is the strategy that provides the process of designing the cloud, integrating the various components for creating a hybrid or a private cloud network, among other things. So basically, a system integrator is a strategy in which you can combine multiple cloud providers. For example, right now you're using GCP and you want to use a certain service from AWS and connect it with your GCP architecture. So you can do that. And system integrators, again, it's not a tool or something like that. It's a strategy or a concept which you can use to create a hybrid cloud network. Okay, so we've seen the basic questions. Now let's get into the intermediate questions. So now first, what's eucalyptus in the context of cloud computing? So we already know what is eucalyptus. It's basically a plant. It's also famous for its medicinal abilities, but in this case, eucalyptus is basically the abbreviation for elastic utility computing architecture for linking your programs to useful systems. So it is basically an open source cloud computing infrastructure which is used for deploying cloud clusters.
Okay guys, a quick info. If you're looking for an end-to-end training on Google Cloud Platform, you're at the right place. Go ahead and check out our Intellipaat's Google Cloud Platform training right now. So now let's continue with this session.
Now you can use eucalyptus. You can basically build your own public, private and hybrid cloud platforms. You can even have your own data center in the cloud, and this can be used to harness its functionality in your organization. So now the eucalyptus concept in cloud computing, basically it's way of doing something, that is the way of creating your own public or private or hybrid cloud platforms, or even host your own data center. So you can use the eucalyptus principles to do this. So it basically is called elastic utility computing architecture for linking your programs to useful systems. So you're basically making your own data center, or you're using a cloud provider to establish elastic utility computing. That is your, for example, if you want to create servers, it should be easily scalable. Now, why do you need the virtualization platform to implement cloud? So cloud is basically virtualization, to be frank. Without virtualization, you cannot have cloud at all. If there is no virtualization, then the companies should provide, basically they should provide individual computer systems to every single user who wants a server. In that case, there won't be enough space to hold all of that computer systems. There is no space to hold that many electronics. But when virtualization comes into place, you can have a single hardware which runs something called an hypervisor, which basically creates these virtualized servers. So now, if you want 1,000 servers, all of those 1,000 servers could be created in one single physical hardware. So now virtualization lets you create virtual versions of storage, operating systems, applications, networks, and so on. If you use the right virtualization, then it helps you to augment your existing infrastructure. You are able to run multiple apps and operating systems on existing servers. So in one single server, even in your own computer, you can basically download Oracle VirtualBox and you can run any operating system on it. So you can create an operating system with, let's say, Ubuntu. You can create one with CentOS. You can create one with Windows itself. So you can basically run multiple applications and multiple operating systems in one single physical server, and that can be done using virtualization. So you can virtualize a desktop, you can virtualize an application, a complete network, you can virtualize storage, and also you can virtualize servers. And that is the main part. Virtualizing servers basically changed the game for cloud. Basically, you can get a data center where you have thousands of physical servers. So in those physical servers, you can create 10,000 of virtualized servers. So you can basically have one hardware which runs multiple servers in it. Let's say 10 users need 1,000 servers for them. So all of those users can have their servers running in one single physical hardware, but if there is no virtualization, they cannot do that. Basically, they would need 1,000 different computers to do that, and that would be a lot of money. So basically, virtualization helped the cloud platform like this. You can virtualize anything, and when you virtualize it, it basically makes it easier for you to access, and it makes the cloud cheaper and cheaper. What are the things to consider before you make a move to the cloud? So now this is a common question. Before moving to the cloud, what are the things you should make sure that does not happen or should happen? So first, you should not lose any of your data while migrating from your on-premise data center or a different cloud provider to a different cloud provider, for example, from AWS to GCP. So you should not lose any of your data. You should have a proper data flow plan which works for you and which can basically transfer all of your data. You should be able to continue with your business within the shortest interval. That basically is planning is required. More than the technology, the planning to do this is really important, because the plan you make and the technology you're going to use will come together to make this process seamless. And when it is seamless, it will be like it should be done within a few hours if your company's data is small, or it can take very less time to do this, and you should make sure it takes, or the migration takes, very less time, so that your business can continue and you can keep seeing profits. There should be fast uptime and data integration with the cloud. So basically, your data center or your cloud network which you're using, GCP, should never go down. Even if it goes down, you should have a failover setup so that when one data center goes down, your application is still running in the other data center and can be accessed. And also, data integration should be provided. What are some popular open source cloud computing platforms? I'll just name 5 of them. So Docker is not a cloud computing tool. It's not a cloud computing platform. It's a tool which can aid cloud computing, which basically helps in creating containers. For example, even inside the servers, you can have multiple containers and make it even better. So if you want to know more about Docker, you can check out in our YouTube channel about Docker. Yeah, you can basically learn more about it and you can also get into it. So now the 5 tools which are open source cloud computing platforms are OpenStack, Cloud Foundry, Docker, Apache Mesos, and KVM. If you want to look more into these, go ahead, Google them, or check out in our YouTube channel. Compare a cloud and a traditional data center. This is pretty easy and most of you would already know the answer to this, but let me just give you a brief. Having a traditional data center and a cloud data center has a lot of differentiating factors. First, the initial cost is high for a traditional data center because you're buying things and setting it up by yourself. But in the cloud, if you're going to use cloud, in that case, everything is already set up in the cloud computing company's data center. You just have to use the product. Second, you can easily scale up and scale down in the cloud data centers, but in a traditional data center, you'll have to buy more servers if you want to scale up, and to scale down, it's practically impossible because you'll have to sell the servers which are idly sitting. Maintenance is a huge cost for traditional data centers, unlike the cloud data center. So if it is a cloud data center, if you are using GCP, GCP, for example, GCP obviously has data centers, and the managers or the security personnel in the data center will handle it. You don't need to maintain the data center. You'll just have to take care of your application which is running on their data centers. But if it is your own data center, in that case, you'll have to invest a lot in maintaining it and securing it. Finally, cloud offers excellent uptime. That is, your application will be up for 99.99% of the time. But if it is your own traditional data center, you will have to make sure that it does not go down. And even if it goes down, you should have a failover plan that basically makes your application stay up. Now, the next question, which is the 14th question, explain what are the different modes of software as a service. So there are basically 2 different modes: single multi-tenancy, fine-grained multi-tenancy. Single multi-tenancy in the sense, in this type, you have your own independent resources that you don't share with anybody. So for example, this particular user has his own application to access their own database. Okay, so every user have their own application running on their own server to access their own database engine. If it is fine-grained multi-tenancy, in that case, so the thing is, even though they have access to these databases, for example, separately, they will be in a single hardware. But if it is fine-grained multi-tenancy, in that case, all the users will have a single application to access each of their databases or each of their data. So in this type of software as a service, the resources are shared between multiple tenants, even though the functionalities remain the same. For a very simple example, if you're using Gmail, the application is going to be the same for every single person, but the data stored is separate for every single person because your mails will be different from the other person, and it should be stored in a secure location, and that basically is multi-tenancy. Single tenancy is an application which you create or which you take up or buy and store your own data in it. What is the benefit of API in the cloud domain? So API means application programming interfaces. So basically, APIs are used to access a certain code. For example, if you use mobile applications to pay money through online. So for example, I'm from India, there is something called UPI. So when you're using UPI and you're trying to pay a certain amount, and let's say you're buying some food and you're trying to pay through a Google Pay or through Paytm. And while you're doing that, when you click on Google Pay and click to pay, it'll basically show you a simple window which asks you to pay over there. So basically, the food delivery app is using the API of Google Pay to access it. So in the same case, how does the API benefit in the cloud domain? First, you don't have to write the complete program. You can use the APIs or the existing code which is already written and embed it with your own code. You can easily communicate between one application and the other because you don't have to hard code anything. It is already available. You will just have to make the connection. For example, the food delivery app doesn't have to hard code its way into paying through Google Pay. They just have to use the API and include it in their code to pay through it. You can easily create applications and link it to the other cloud services. It seamlessly connects between these two applications. There is no problem. You just click on the button to pay. It'll take you to the other application. You can pay and it'll bring you back to the same application where you started. So same thing happens in the cloud services as well. 16th question. What is the difference between elasticity and scalability? So first, let's look at scalability. So scalability in cloud is the way in which you increase the ability to service additional workloads, either by adding new servers or accommodating it within the existing servers. For example, let's say your application is running really well right now and there are 10 servers being under use, and suddenly your application becomes a hit and there are so many users and you need around 100 more servers. So right now you have 10 servers and suddenly there is a need for 100 more servers, and cloud can provide you that. You can easily scale 100 more servers immediately and accommodate all those users. And let's say in the next day the half of the user base has been reduced because they are sleeping, or let's consider like that, it's nighttime, they're sleeping. So now your user base is around, so right now you needed 10 plus 100 servers, so 110 servers are running. Suddenly your customer base has been reduced to half. So in this case you only need half of it, that is 55 servers. And so basically if it is running on the cloud, you can basically set it up so that it checks the workload and reduces the number of servers accordingly. Now coming to elasticity. So elasticity is the process by which you can either add or remove virtual machines depending on the requirement in order to avoid wastage of resources and reduce costs. So elasticity is basically you can basically remove it or add more according to your requirements. So there it is completely elastic, that is you can basically delete it or increase it or remove it whenever you want. There is no restrictions. So this is basically the difference. Scalability basically is adding new servers or reducing the number of servers according to the workload. Elasticity is basically your own process or your own way of increasing or decreasing virtual machines to avoid certain costs or wastage of resources. Now, how important is the platform as a service? So now platform as a service is obviously important, and you can get an application layer and it lets you have the complete virtualization of the infrastructure layer, and this way you can work it like a single layer. So that is, you the user basically get a platform in which you provide all the details and upload your code, and the cloud provider will handle loading that data into a server to host your application. So you don't need to manage any infrastructure, that is you don't need to manage the servers, you don't need to manage the storage, you just have to manage the platform in which you uploaded your code, and basically it stays in the middle. So you can see over here application clients, service provider, which is basically GCP in our case, and data center has the servers. So when you upload your code and you want to host the application, it will be automatically hosted in a server. And if you need certain software and operating systems, you would have mentioned what kind of servers you need, what kind of an operating system you need, how much memory you need, how much compute power you need, and any other cloud service. So GCP is the central part. So now this particular part is in GCP, and your website which is being hosted in the server can be used by end users. So when they're trying to use your application, they can they will not know it is hosted on GCP. You are the person who knows that, and it makes it really easy because you can just work with the cloud computing technology with just one single web page. Okay, so we've seen this. Now let's move on to the advanced questions. So now, how will you request more quota for your project? So quota in the sense, for example, if you are a free account or something like that, there will be certain restrictions. For example, let's say you can only run 30 servers right now. That is your quota. But your project needs 50 servers. So in that case, what can you do? You only have 30 servers. So in case you have to increase the quota limit, you will have to basically request it. You can request more quota directly through the edit quotas button on top of the page. So on top of the page on GCP's website, you can find edit quotas button and you can change the quota over there. And some default quotas are provided to all the Google Compute Engine projects, and when it exceeds the quota, you cannot go more than it. And basically, to increase the quota limit, you will have to request for it. And to request for it, you'll have to click on the edit quotas button. Okay, what is object versioning in GCP? For example, an object is basically something which you store, an audio file, a video, a PDF file, all are objects. These are binary objects. And object versioning is basically to retrieve objects which are overwritten or deleted. So whenever you're uploading a certain image, let's say you're uploading that image 5 different times and you made a simple edit each and every time. So you want your latest version to be available on the main, let's say it should be available in the front. And if you want to access your older versions, you can, because even though you uploaded the same image with the same name 5 different times, but whenever they got uploaded, they would have been given a version.
Okay guys, a quick info. If you're looking for an end-to-end training on Google Cloud Platform, you're at the right place. Go ahead and check out our Intellipaat's Google Cloud Platform training right now. So now let's continue with this session.
So let's say the first image you uploaded is number 1, version number 1. So number 2, 3, 4, 5. So now the latest version will be displayed and the other versions will be stored even though they are not visible. So if you want to view them, you'll have to go into that particular object and view all the available versions. So now object versions can be enabled in GCP. If you don't want object version, you can still disable it. And when you enable object versioning, if it is the same object being uploaded, and it basically removes it will not be overwritten or it will not be deleted. The properties used to identify a version of the object are generation and meta generation. Generation identifies the content generation, while meta generation identifies the metadata generation. So generation in the sense content generation, the number of images which are keep coming. Meta generation basically identifies metadata, which basically is the size and all the other small details. So object versioning is the different versions given to an object which is uploaded again and again so that you can avoid overwriting. Now, how does cloud computing provide on-demand functionality? So we already know what is on-demand. It is basically providing you the service immediately when asked for. So now cloud computing as a technology was created on the pillars of providing the functionality to all its users on demand, anytime, anywhere. If you have a device with internet, you can get a server immediately. So that is what was promised when cloud computing was created. With the latest advancements and easy access to applications such as Google Cloud, the idea is much easier realized than earlier. With applications like Google Cloud, a user can view the files on Google on the cloud on any device at any time of their preference, no matter which part of the world they are in. For example, if you have something called Google Photos, you can basically experience this. You can view a photo which you have taken on a particular day, let's say 2 years back, even now, by just searching for it or by looking into it, but you just need internet to view that. So it's basically on-demand functionality. So now how they provide on-demand functionality is that they have a huge data center with amazing compute power, and you can basically, if you have internet, you can view or you can use their services anywhere from at any time. Basically, what are the libraries and tools for Google Cloud Storage on GCP? At the core level, you need XML API and JSON API, which are available for cloud storage on Google Cloud Platform. But along with these, there are other options provided by Google to interact with cloud storage. So you have a Google Cloud Platform console, which is basically the website, and using that website, you can perform basic operations like creating a bucket, uploading an object to the bucket, deleting it, enabling object versioning. So you can do all of this in the website. Second is a Google Cloud client libraries. So in this case, it provides programming support to languages like Java, Ruby, and Python. You can basically code it using this client libraries, and you can access the storage. That is, you can access the objects and buckets using your code. Third is a gsutil command line tool. So now you have certain commands which you can use on the command line tool to access the objects and the buckets. How are the Google Cloud Engine and Google Cloud App Engine related? It's not Google Cloud Engine, Google Compute Engine and Google App Engine related. So first, Google Compute Engine and App Engine are complementary to each other. So Google Compute Engine is an infrastructure as a service product, where Google App Engine is a platform as a service product. So now Google Compute Engine is the service which will provide you servers on demand. Google App Engine is the service which will provide you a website in which you can upload your code, and it will basically handle the provisioning of servers and uploading your code into that server and hosting it for you. So Google Compute Engine provides you the server itself, where you can log in and use that server completely, which basically provides you the infrastructure. Google App Engine provides you the website, which is the platform which you can use to upload your code, and all the other things like provisioning the server, logging into it, and hosting your code will all be done by Google App Engine itself. But Google App Engine needs Google Compute Engine. Without Google Compute Engine, it will not have a place to host the application. So now Google App Engine is generally used to run web-based applications, mobile backends, and even line of business. So if you want to keep the underlying infrastructure in more of your control, then Compute Engine is the perfect choice, because when you basically create a server using Compute Engine, you can provide your preferred operating system. You can provide the memory you need. You can provide how much compute units you need. You can provide let's say storage. You can provide every single aspect you need your server to have, and that basically gives you more control over the server. But if you don't want to waste time on provisioning the servers and looking into each and every detail of the server, you can basically go ahead with Google App Engine. And in this case, you are just uploading your code. You can concentrate more on your code and your application rather than the server itself. So once you've done with the application, you upload it to Google App Engine, and Google App Engine will take care of provisioning it for you inside the Compute Engine server. For instance, you can use Compute Engine for the implementation of customized business logic, or in case you need to run your own storage system. Okay, so now as I told you, Google App Engine, you can basically upload your code. It will handle everything else. If you want to host a website on your own inside a server, in that case, you can basically go ahead with Compute Engine, and you can basically install all the softwares you need, and then you can basically upload your code and host your application. Now, what is a bucket in Google Cloud Storage? So buckets are the basic containers that are used to store the data. So buckets are basically like folders where you can upload data. You can basically organize data and also give access to certain users, and you can basically restrict access from certain users. The bucket has a globally unique name with geographic location where the contents are stored. It also has a default storage class that is applied to the objects which don't have a storage class specified and are added to the bucket. The storage class basically means whether this object will be taken, downloaded or uploaded frequently or infrequently, or this has to be archived somewhere. It won't be used for multiple years. It has just to be stored like a backup. So these are different types of storage classes, and that will be assigned to the object or the files which is being uploaded. There is also no limit on the creation or deletion of buckets. You can create any number of buckets. You can and you can store any number of storage as well, objects, and it basically does not limit you. You can store 1 GB of data, 50 GB of data, 1 TB of data. So anything is fine, but you'll just have to pay the price for it. Now, what is serverless computing? So this is really important. So in serverless computing, the cloud service provider has a server running in the cloud and dynamically manages allocation of resources. So this particular sentence has to be understood very carefully. So the server is already running. You're not going to provision the server. The server is already running. Serverless does not mean there is no server. Serverless means you don't need to access the server by yourself, or you don't need to provision the server by yourself every single time you need to do something. The server is always running, and whenever you have a certain task, only at that time resources will be allocated for you on the running server, and your task will be done. And once your task is done, that's it. You cannot use that server again, because only when the task is happening you will be provided permissions to use that server. So in this case, you don't need to worry about the hardware, you don't need to worry about the server, you just have to worry about the code you are going to run on it. So the users need to pay for the resources they have used. Basically, you're not using the complete server, or you're not using the server for the entire time, because let's say your code, whenever it is run, it takes 2 seconds to run. So every single day, your code is run 100 times. So 100 into 2 is 200 seconds. So you'll have to only pay the money for the 200 seconds of the usage of the server which is running. That's it. So this basically decreases the cost you spend on a complete server which is running all the time. You don't need to do that because you're only paying for the seconds which your code has used the particular server for. Also, you don't need to worry about provisioning or scaling the server because whenever there needs to be more servers for your code to run, the cloud provider will automatically do it for you and they'll automatically maintain it for you. So this is what special about serverless computing. Serverless computing does not mean there is no server. There is a server or there are multiple servers which are already running. You will just have to basically concentrate on your code, and whenever your code runs, the code will be allocated certain resources on the running server and you will only have to pay for the seconds or minutes it runs on those servers. So now, what is load balancing in cloud computing? So load balancing is the process of distributing the computing resources and workloads in cloud computing environment to manage the demands. It helps to achieve high performance for lower costs as the workload demands are efficiently managed with the allocation of resources. To be very simple, load balancing is basically, from the name itself, you're balancing workloads in the sense incoming traffic. So let's say there are 100 users who are using your application right now and there is one server which is able to handle all of them. Suddenly there are 300 users, but this particular server can only handle 100 users. In that case, you would need 2 more servers to handle all the 300 users. Otherwise, your application will not be able to handle the incoming traffic and the server might slow down and crash. So you would need more servers. So now that is basically auto scaling, or that is scaling. But let's say even though you have 3 servers, so 300 users have come in. Right now there is only one server. Basically the code you have or the auto scaling tool you have basically identifies that there are more users and the workload is increasing and basically creates 2 more servers. So now there are 3 servers and there are 300 users. So now here is where load balancing comes into play. If there is no load balancing, the 300 users can be assigned to a single server and again the same problem will occur. But with load balancing, what happens is the incoming traffic is evenly distributed or distributed according to the weightage you have provided. 300 users, let's say one server can handle 100 users. So now when there is load balancing, it will split the incoming requests to each of those servers. So let's say a request comes, it goes to server A. Another request, it goes to server B. Another request, it goes to server C. So this process goes on. So this is basically traditional load balancing. There are other forms of load balancing as well, but here I'm not going to discuss all of them because that is a completely different video. If you want to know more about load balancing, again, you can go check out our YouTube channel. We have videos on load balancing. So now it uses the concept of scalability and agility to improve availability of resources to the demands. It is also used to provide health checkups for the cloud application. So load balancing can also be used for health checkups, which basically means it checks whether a certain server is healthy. Healthy means whether it is running properly and has the application running on it. So you can also use load balancing to do that. And mainly it is to basically allocate the workload across multiple servers and efficiently handle and manage the allocation of resources to the incoming traffic. So this service is offered by all the major cloud providers. GCP, AWS, Azure, all the major cloud providers provide load balancing because without load balancing, it's really tough to handle a certain website. Okay, so that is the 25th question and that is the end of the session.
Okay guys, a quick info. If you're looking for an end-to-end training on Google Cloud Platform, you're at the right place. Go ahead and check out our Intellipaat's Google Cloud Platform training right now. Okay guys, we've come to the end of this video. I hope this video was informative and helpful for you. Also guys, please subscribe to our channel if you haven't done yet for our upcoming videos, and also leave a like to our videos if you really enjoy our content. Thank you. Meet you in another session.